in the jar, okay, there is 3 blue marbles and 4 red marbles. Okay, so 2 marbles is select at random. Okay, so which I select the first one and then not replacing. Okay, get the second one. So this is called dependent probabilities, because the second stage, okay, is depend on the first stage. Okay, the probability will be changed. Okay, depend on the outcome of the first event. So let's go. Okay, so these are the questions. Find the probability of blue and red in any order. The probability of both marbles are same color, and probability of blue and red in that order. Okay, now before we answer any question, of course we draw a tree diagram, so makes it easier for us. So first, if I draw the first marble, I either get a blue, okay, or a red marble. Okay, so the chance of getting a blue is 3, okay, out of 7. Okay, so 3 out of 7, because blue I have 3 and red I have 4. So the chance of getting a red, okay, is 4 out of 7. Now the first one, let's say if I get a blue marble, so what that means is a blue marble is gone. Okay, we cross it out because I already take 1 blue out. So you notice that I have 6 more marbles left. Then to get a marble, I either get a blue or a red. Okay, now because I took 1 blue out already, as you can see, so I have 2 more left. Okay, so to get a blue, I got 2 out of 6 marbles. See, now to get a red, because I already took 1 blue out, so the red's still the same, which is 4, but this time only 6 marbles left. There you go. Okay, so that's what it is. Now let me clear the cross out first, because to make it clear for you, because in this stage, okay, this time what happened is this: I getting a red marble first. So what that means, if I getting a red marble on first draw, so this is gone, right? So you're left with 3 blue and 3 red. So therefore, okay, the chance of getting a blue is 3 out of 6, and then to getting a red is 3 out of 6. There you go. Okay, this is the 3 diagrams, and then the sample space is blue blue, blue red, red blue, and red red. Okay, these are sample space, but of course the probabilities of each of them are different. Okay, so let's answer these questions. Okay, now the probability, okay, of getting a blue and red in any order, that means I can either get a blue, okay, red, or red, blue. Okay, so this is the one I'm gonna highlight for you, so you can see which one it is. Okay, so to get that, let's say blue red, so blue red or red blue. See, you can see that, which is equal to 3, 7 times 4, 6. I run a space, add 4, 7 times 3, 6. See, now if you put that in your calculator, okay, you should get 4, 7. Okay, so 4 over 7. Now, the next one. Now the probability of getting the same color. Okay, so both of them have the same color. So same color, which is equal to, now same color is, so blue blue, okay, this is one here, okay, blue blue, and then red red, okay, blue blue or red red, which is blue blue is 3, 7 times 2, 6, right? Add 4, 7 times 36. And if you put that in your calculator, you should get 37. Okay, so that's what you should get, 37. Now, last one. It said the probability of getting a blue and a red in that order. Okay, so the probability of blue and red. Okay, so in another word, find the probability of blue followed by red. That's what I meant. Okay, so which is equal to this one here, blue, red. So blue and red, this is one here. So we go 37, okay, times 46. There you go. So if you put that in your calculator, you get 27. Okay, so this is called dependent probability. The second state of the probability is different from the first state because the outcome of the second, it depends on the outcome of the first. Let's move on next one. Now, I have 4 cards, 4, 5, 8 and 9. So what I do, I shuffle, okay, and then put them face down. So, and then I select 2 cards randomly, okay, select 2 cards and then form 2 digits number. Okay, so the questions are probability, find the probability that's greater than 50. The probabilities of getting even numbers. Probability that between 40 and 60. Okay, and the last one, find the probability that the first digit is greater than the second digit. Now, the way to go about this is I draw a tree diagram. Okay, so I just move this across first. 4, 5, 8, 9. So in another word, when I select the first digit, I either get a 4, okay, or a 5, or a 8, an 8, or a 9. Okay, now let's say if I select a 4 already, okay, the number that still remain face down is 5, okay, 8, or 9. Now if I select a 5, okay, a digit 5, okay, so the second one I either get a 4, okay, a 8, of course, then no more 5, and 9. Similarly, if I get an 8, so the next draw could be a 4, let's just try 4, a 5, or a 9. See, if I select a 9 at the first place, so the second times I either get a 4, okay, a 5, or an 8. Okay, so I just connect these together. So this is my tree diagram. Okay, so this is the numbers. So then when you got this, the rest are very, very easy. Okay, so question says, first one here is, what is the probability, okay, that number that greater than 50? So the best way to do is I just write out all the sample space first, so then I can answer all these questions. So the sample first space for the first one is 45, 48, 49, 54, 58, and 59, 84, 85, 89, then 94, 95, and 98. You see, these are the outcome sample space. Yes. Now, for greater than 50, okay, I just take the one that greater than 50, which is 54, 58, 59, and then 84, 85, 9. All these numbers are greater than 50. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the properties 9 out of 10, 11, 12 out of 12. See, there you go. If you simplify that, divide by 3 for both of them, the answer is 3 over 4. See, there you go. Now, let me just clear this first. Now, second one is, what is the probability of getting an even numbers. Okay, even numbers is the last digit must be even, right? So these are the one. Okay, so even 48, 54, 58, 84, 94 and 98, which is 1, 2, 3, 4, 5, 6. So which is 6 out of 12. Okay, 6 out of 12 is a half. You see? Now, let me clear this thing first. See? Okay, now the probability, okay, that between 40 and 60 inclusive, yes? So between 40 and 50, 60 is this number, 45, 48, 49, 54, 58, 59. Okay, these are the numbers. 1, 2, 3, 4, 5, 6. So which is 6 out of 12. So 6 out of 12, which is a half. Find the probability of the first digit, okay, must greater than the second digit. So which is the first digit must be greater second, so which is 54. This one, the first bigger than the second, so 84 and 85, 89, 94, 95 and then 98. Okay, these are the numbers. So 1, 2, 3, 4, 5, 6. So same thing, 6 out of 12, which is a half as well. Okay, so this is called dependent probabilities. Okay, so just remember that for me. Thank you so much for watching my videos.